All right, let's talk about the AI chip race. It is an incredibly hot topic right now. And, while everyone is focused on these amazing new custom chips from Google and Amazon, there's a much, much bigger story playing out here, one that goes way beyond the tech we're using today.
I mean, it's easy to look at these processors and think, wow, this is it, we've hit the peak. But is that really the case? Are these custom AI chips the absolute summit of what computing can do?
The short answer? Oh, not even close. What we're witnessing right now isn't the final chapter. It's actually just the end of the first one. And to really get why, we need to look past the silicon that's powering our world today.
So, to truly grasp the importance of today's chip boom, we've got to first understand the fundamental limits of the computers we use every single day. This is the stuff we all know. Classical computers, everything from your phone to the biggest supercomputer, they're all built on silicon, and they think in binary, ones and zeros. They chew through information step by step. Now that's incredibly powerful, but here's the catch. It has a physical ceiling. There's only so far it can go.
And this is where the entire rulebook gets thrown out the window. See, quantum computing isn't just a faster version of what we have. It's a whole new ballgame. Instead of that linear step-by-step process, it taps into the truly weird rules of quantum physics to explore a massive landscape of potential solutions all at the same time. It is a fundamentally different and, for certain problems, an exponentially more powerful way to compute.
So what kinds of problems are we talking about here? Well, the challenges that quantum computers could tackle are just on another level entirely. We're talking about things like designing brand new materials from scratch, creating perfect simulations of molecules to discover new drugs, or cracking codes that are completely unbreakable today. These are the kinds of problems that would take the fastest supercomputer we have longer than the age of the universe to solve. No exaggeration.
So, here's the crucial takeaway. Today's incredible AI chips, they're best understood as a vital but intermediate step. They are all about squeezing every last drop of performance out of our current technology before we make that next great leap. Okay, with that big picture context in place, let's zoom right back into the present day. Let's look at the key players who are driving this intermediate step: Google and Amazon, and their massive investments in custom silicon.
We're really focusing on two giants of the cloud world. Both Google and Amazon are pouring billions of dollars into designing their own AI chips. But, and this is the interesting part, they're doing it for very different strategic reasons.
So you might be asking, why go to all this trouble? Why build your own chips? Well, it really boils down to three core reasons. First, cost. Running these huge AI models is incredibly expensive. Second is power. These data centers use an absolutely enormous amount of electricity. And third is strategy. They want to be less dependent on any single hardware supply.
And this slide lays out their different game plans perfectly. You've got Google with its Tensor Processing Unit, or TPU. They're now basically selling access to these custom chips to their customers. Amazon, though, is taking a different path. They're keeping their Trainium 3 chip all to themselves, using it internally to slash the operating costs for their own cloud services.
You can think of Google's TPU as a hyper-specialist. It's built for the kind of predictable, massive volume jobs that Google handles every single second. Things like your search queries, YouTube recommendations, training those giant language models. For those specific jobs, it's an absolute master of efficiency.
But, and this is a really big but, this rise of custom chips doesn't mean it's game over for the current market leader. Not by a long shot. So here's the billion-dollar question that's probably on your mind. With tech giants like Google and Amazon building their own stuff, is a company like NVIDIA, which has just dominated this space, about to become obsolete?
And the answer to that is a very clear and simple no. Think of these custom chips like a Formula One race car. On a specific track, under perfect conditions, it's absolutely unbeatable. But you wouldn't use it for a trip to the grocery store, right? These chips are amazing, but only in very specific, highly optimized situations.
NVIDIA's general-purpose GPUs, on the other hand, they're more like a high-performance, all-terrain vehicle. They're still absolutely essential for a huge range of less predictable, more varied tasks, the kind of pioneering work you see in research labs and startups. We're talking about generating AI video, designing new medicines, building autonomous robots. Their real strength is that amazing versatility to tackle almost anything you can throw at them.
So what does this all mean when you put it together? Well, we're seeing a new, much more diverse hardware map taking shape, where you have different tools for different jobs.
So let's break down this new reality into three simple steps.
Number 1, for huge repetitive tasks at scale, specialized chips are going to win on cost and efficiency every time. Number 2, for pretty much everything else, especially for research and development, general-purpose chips will continue to be king. And number 3, this means big companies will start using a mix of both. Hardware diversification is the new normal.
And you know, this isn't some brand new phenomenon. We've actually seen this movie before in the history of computing. Specialization always pops up to make common tasks more efficient, but it never, ever completely replaces the flexible, general-purpose systems that really drive innovation forward.
Okay, so now let's pull the lens all the way back out again and connect all these dots. This whole race, this diversification of hardware, it's all about building a bridge to the next great era of computing.
We're coming back to this central idea of a bridge because it is just so critical to understanding what's happening. This custom chip boom is not the final destination. It is the bridge we're building with the tools we have right now, squeezing every single ounce of performance from classical computing while the future is being built.
To put it as simply as possible, chips like Google's TPU and Amazon's Trainium are the absolute pinnacle of the classical silicon-based world. They are the final, most refined version of an old way of doing things, all happening just as a new quantum paradigm is starting to appear on the horizon. And all of that leaves us with one final, fascinating question to think about. Classical silicon chips gave us the information age, which completely transformed our society. So if that was just the end of the beginning, what new age, what unimaginable new possibilities will the dawn of quantum computing unlock for all of us?